And so I just starting in November of last year, I was funded through the CDFA Specialty Crop Grant program for promoting Moringa in the state. So today's talk will really just be on what Moringa is and how it relates to the other species within the family, its history and uses, why we should eat it both nutritionally and for health reasons. And then I'll go through some of my work. Prior to the CDFA grant, I was on a 5-year Fogarty International grant. So we were mainly working in Kenya with Moringa farmers there. So I'm now kind of bringing this knowledge from Kenya and other farmers I've worked with in South America and India, and kind of seeing how we can operate this within the state. So Moringa is in the order Brassicales, which is where you find the other cruciferous vegetables like broccoli and cabbage. So Moringa has that kind of wasabi or spicy arugula taste to it. I'd say it's a mix between spinach and arugula if you eat the fresh leaves. The roots themselves taste exactly like horseradish, and the pods form these long, hard sticks. So it's also called the drumstick tree, among a lot of other names. It grows in semi-arid and tropical and subtropical areas, and really kind of throughout just the whole middle belt of the world, which, as we know, because of climate change, is now expanding into other regions. So these are some very general guides. It's a fairly adaptable plant. However, it does not like a frost or the cold. So this is a tree that's been growing at the Horticulture Innovation Lab at UC Davis, and you all are welcome to come and visit once things are available to do so. And we've been able to like prune it back in the winter, and then in the spring it can sprout again. So part of the project will be to try growing Moringa in some of these microclimates within California. It's already been cultivated in the Central Valley for several years by a lot of Hmong residents there. So in terms of its nutrition, it's 27% protein by dry weight. So once you dry the leaf powder down, it contains all essential amino acids, including high levels of lysine and methionine, which are often limited in a very staple food-based diet. So general recommendations are around a heaping tablespoon, which is about 10 grams. And they've done some pretty interesting studies with this where they've combined it into snack food and seen fairly strong results. However, the clinical interventions are fairly limited. And so far, no studies have been funded by the US government for looking at Moringa to address malnutrition. But you can see even combining like a 3-gram bit of the powder into snack foods can increase hemoglobin levels, vitamin A levels, and folic acid levels. There's also been a lot of work basically looking back at the traditional uses of Moringa and now trying to do studies. So increasing breast milk supply for nursing mothers has been a fairly well-established effectiveness as well. So far, all human studies have found to be Moringa safe at the doses that they've been delivered in. However, obviously more safety studies are always needed depending on how the Moringa is delivered and where it's grown, how it's processed, all of these quality control concerns. I'm not going to go through all of these numbers, but the main thing to point out is that Moringa is nutritionally dense, in part because it contains a lot less water than most plants. So if you put any other vegetable up here, the water content would be about 90 to 98% water, right? Lettuce, iceberg lettuce is like 99.5. More dense kales would be around 85. So that's why when you dry it, you really bump up a lot of these nutrient levels that you find in it. And when you start to look at meeting some of the needs of women, and this would be very similar for men as well. We were just focusing on women and children for a grant I was using this for. So you start to see some really impressive things like vitamin C and vitamin A, iron. And so the idea is then to use this powder to supplement foods as a food security means. and just to improve nutrition overall. So I really became interested in Moringa as a Peace Corps volunteer in West Africa for these nutritional interventions, but then became more curious in a lot of other plants that they were using because there just aren't doctors around. So kind of the moms and the herbalists are really the doctors that you go to. And so that's when I discovered what pharmacognosy is, and looked into PhD programs so I could help kind of translate and work as a mediator between more traditional medicinal practices that are based in thousands of years of trial and error, and then very modern science that works, at reducing variables and coming up with evidence-based solutions. This are some of the other potential health benefits that we are continually looking to apply for grants for to explore in clinical studies. This is a rat card that we developed in Kenya as part of our program and had it translated into Swahili. So I'll be modifying this a bit for California and to fit it into a smaller thing and have a QR code and update the technology a little bit of the information. This is a summary of some clinical studies that have been done with Moringa, just highlighting both animal studies and then humans with diabetes has been a main focus of the grant and reducing inflammation. This was really the Fogarty NIH grant. So you can see that it lowers glucose levels and HbA1c, and then in hyperlipidemic patients, it was lowering cholesterol levels as well. So this is, again, just kind of information summary, but you can just see that the study designs that have been done on Moringa have ranged from postmenopausal women and then a huge chunk really on diabetes. And this is where you see a strong parallel between the traditional uses of Moringa and modern ailments that we're facing and how cultures are using their solutions to address these issues. So just to kind of give you some chemical background on Moringa, these are some polyphenols. These are compounds and antioxidants that all plants make to protect themselves from UV damage, oxidative stress. So when we consume these compounds, they also provide some protection for us. However, they're not as well understood and they're usually not as bioavailable in the body. So we're still learning about why grapes and these things are so good for us. We see the health benefits, but understanding the mechanism of action is still kind of being understood and likely involves complexities within breakdown products and the microbiome. But what makes Moringa really interesting is these isothiocyanate compounds. They're also made by plants and like in the Brassica family as plant defense compounds. So the idea is you can think of this kind of like a grenade with a trigger in it. So the plant stores it and it's fine and it's protecting itself. But if any insect comes and tries to bite it and attack it, it basically pulls that pin out by cleaving off the sugar through an enzymatic reaction and releases this very potent, spicy kind of mustardy taste to the insect. So the insect leaves and then it evolves to kind of produce these compounds under attack. This compound, these isothiocyanates are really well understood from broccoli and really highly researched for cancer prevention and treatment. So the precursor in broccoli, when it is raw and hasn't been eaten or cooked, is glucoraphanin. When you chop up broccoli or you chew it or you cook it, you get the same enzymatic reaction and you release sulforaphane, which is a potent natural product, but it's very volatile. So it evaporates. And in the case of Moringa, the product has another sugar on it. And so it's stable at room temperature, allowing it then to be made into health products, agricultural products, animal feed products as a health preventative compound. We've demonstrated its stability compared to sulforaphane. And then this is just a review of specific activities of these compounds, showing reduced inflammation, blood sugar regulation, antioxidant activity, and then other very kind of broader biological health concerns. So what's interesting, once you know about the chemistry, you then step back to what's happening in the field. So traditionally, moringa is cultivated fresh and dried and then ground to a powder. But when you do that, you destroy that enzyme. And so you never get the breakdown product that's so beneficial for us to eat. So part of this project was to look at new ways to process the moringa, such as grinding it or rolling it. And we were looking for real low-tech solutions with bicycle blenders, and just, I think in the end, we ended up putting it in a rice sack and just beating it. It's the same thing you do when you crush garlic, with the side of a knife. You're releasing that enzyme. And then we worked on some extractions just using water. So this is like a tea, a moringa tea, basically. And these are some commercial products that show that the levels of these isothiocyanates often remain low or nil. We then took this moringa concentrate, this tea, and dried it down to evaluate it in some animal studies and some in vitro cellular assays. So I'll just go through kind of what we did. And I'm not going to get into all of the science, I'm happy to, but this basically showed that we reduced the expression of inflammatory cytokines with both the moringa concentrate in a dose-dependent manner and with the purified moringa compound. So 1 micromolar is a very low and effective dose. You're almost getting to like a pharmaceutical effect with these compounds. So again, polyphenols take a much larger amount before you would see an effect in an assay like this. We showed that in liver cells, moringa and the purified compounds behave in a very similar manner to metformin, which is the common prescription drug for diabetes. It basically works by preventing glucose production in the liver. So you'll see this is 2 millimolar. And this is 1 micromolar. So this is, 2,000 times less the concentration of the prescription drug that you could be getting from a food source, which is pretty cool. And then we also compared it to sulforaphane from broccoli. We then did an animal study where we took 2 groups of mice and fed them both a very high fat diet. And then 1 group received 5% of their food was coming from this moringa concentrate, and they were equaled out for calories. The moringa fed mice did not gain as much weight. They also showed, although they showed lower fat accumulation, they did show increased free fat mass, which is basically the same as muscle mass. So they're decreasing their fat while increasing muscle, which is a good thing. It shows that it's not toxic, and it also correlates with what we've seen where people are feeding it to their cows and chickens and goats to build both meat and milk. We showed that the moringa fed mice had a nicer response to blood glucose, which is through an oral glucose tolerance test. And then this is, this is the liver of the very high fat fed mice. So you can see overall, they were much heavier, and of the moringa fed mice. So this is the histology. So all this white stuff is fat, basically. And this is the lipid content. So it was about 3 times as fatty of a liver as the moringa fed mice, despite them having the same amount of fat in their diet. So this is pretty cool, although graphic, and good evidence to kind of move forward into clinical studies with this plant. More diabetes stuff that we just did at UC Davis with an improved model for diabetes in humans. We put in a couple of applications for using moringa to both prevent and delay and reduce symptoms of COVID-19 because of its relation to inflammation and metabolic syndrome, viral susceptibility, and food security. This was kind of the summary of the K01 grant that we have been working on. So to develop moringa as both like a fresh and a food security tool with the nutrients and phytoactive compounds, better understand how these compounds are actually working in the cells, and then do these in animal and hopefully clinical studies. So we have an intervention now in Kenya where it's a group of farmers that have started growing moringa, and now they're going to be adding their powder into their porridge. And we're measuring both willingness to adopt, and then we'll be taking blood samples as well for some of these health markers. So the kind of ag, that was a lot of science, and this will be maybe hopefully a little more relevant and easier to digest. But see, these are some of the community development training programs we did, where we looked at recipes and processing and construction of dryers. We developed these rack cards for simple instructions on how to plant and grow moringa. Again, these will be modified to meet the Californian climate a little bit better. And these are some Feed the Future design chimney dryers that we constructed in Kenya that I've definitely had some challenges with in terms of the sustainability of the materials and the cost effectiveness of them and just uptake from them. So we've kind of modified our approaches. This was one grower up in Meru. This was his drying structure that we were able to apply some of those principles of convection and put in a vent, and that was just that was probably 400, 500 bucks, but it was a central processing place for all of the growers in the area. And he reduced the drying time from 3 days to 1 day. So just simple things like this, definitely out of my realm as a chemist, but moving from kind of what I see as a very relevant plant to then, you know, the implementation part of it. So this was when we met some of the farmers in Meru. Their current moringa cultivation was for about a meter apart. But through my research, I learned of this intensive moringa production, which was originally designed for livestock feed, where you plant them as close to 10 centimeters apart, and you can harvest like every 35 days with irrigation. So now this one is ready for harvest. There's also some pretty interesting research on intercropping with maize, cannabis, avocados, because moringa is a bit curious. It's not a legume, yet how does it have all this protein if it's growing in sandy soils? So our hypothesis is that it is fixing nitrogen from the air through endophytic bacteria, actually. So it's then potentially transferring some of the nitrogen to neighboring crops. Hasn't been tested yet, but we've at least identified some nitrogen fixing bacteria within the seeds. We just haven't been able to show precisely that they then are acquiring that nitrogen. But it's quite fascinating. Most plants used to be able to fix nitrogen. However, as we then selected for crops and used fertilizer, they no longer needed to make nitrogen in some ways. So we really deselected out for that trait out of a lot of crops. We did some trials to kind of show the farmers how much more productive an intensive field would be, because again, showing them a paper doesn't really help them. And for example, you know, despite the data showing, we didn't get a third round of this, so I never published it, but generally about a 10 centimeter spacing is good. But some of them said, look, like, it's just hard for me to walk through there to bend over. So we're going to go down to like a 20 or a 50, but we will stop planting at the meter apart. So these are the kinds of conversations that are really good to have with groups, because it's just, it has to come, again, as you all were saying, from the ground up. I can't be going over there with solutions in mind that are out of context. These are just some of the gatherings we did. We brought some of the farmers from Kisumu to Meru so they could talk and share information about their different planting methods. Some of the products that the co-op has developed that includes moringa and stevia as a tea. And we then did, we were trying to see really what's the economics of this, because again, promoting a crop is quite dangerous just based on nutritional value if you're not looking at the economics of it. But just because it's so productive, it's pretty tempting already to kind of see this, how it could produce a lot more than for, say, maize. And not that a farmer should transfer all of their production into moringa, especially if there isn't a market. but maybe a percentage would be wise. So we did do a land use systems analysis in Kenya with the assistance of the International Ag Development students. So I had a graduate student and then a RIFA fellow come out to Kenya to do the interviews with the farmers. And it was pretty impressive with what the co-op was doing, generating an NPV of about $8,000 per year. And we're generating incomes higher than the local prevailing wage rate. This was a local company selling on a local level, no organic certification. It took us a while to get the paper published. We had some other things happen, as you all may know, in academia. We actually started this in 2017 and just published it in January. In that time, we met another company at the coast of Kenya that was organically certified and exporting to Europe and the US. We then went in and did the same land use systems analysis, and we're able to compare those two business models. So this is published, and again, it just really points to the fact that it is not about the intervention itself. It's not that Moringa can end poverty. It's how you implement it and where it works. So in the case of the cooperative, they were generating income. In the case of being a contracted farmer for an export company, they were well below the poverty line. They were receiving about 35 cents a day. So that's not a socially equitable business model. And some of these companies don't have the tools to look at this. So we're trying to offer these kinds of perspectives so that ag interventions, or any intervention, goes through a triple bottom line analysis: social, economic, and environmental. We've looked at the quality of different Moringa products also. So this kind of world of these superfoods being grown overseas and then shipped into kind of Western culture, the quality is not always better necessarily either. And we've certainly found trace elements and metals in organically certified Moringa products that are coming in. This is partly due to the fact that Moringa is a bioaccumulator, right? It's pulling up all these nutrients. But if it's growing in a soil that's contaminated or just naturally abundant in arsenic or a metal, it will pull those up too. So again, you have to test the quality of it. And that's why also growing your own provides you some sovereignty and some knowledge about what it is. So this new project that we've just started, and this first one is the talk I'm giving you now, is just awareness about Moringa. And then we'll be doing another training on cultivation and consumption, and then another one on processing and preservation. I wrote this grant in 2019 before COVID-19. And so we are just seeing how things are going and trying to do what we can in person now that spring is coming, and what we can virtually, and then offering, like, I can mail out seeds to people and participants that aren't able to meet in person. And this project will include highlighting some of the growers that are already operating in California. This is Kayang Mua in the Fresno Valley. This is her beautiful Moringa farm that she's had going for, I think I want to say 5 to 7 years. And they're really growing it for pod production mainly, and selling it at local farmers markets. She's been involved with some other CDFA grants to try and look at cottage certification and how do they get to market. So there's a large group of these farmers down there, and they kind of found the same thing. You know, they said, we're selling our fresh vegetables at the farmers market, but when we go to the store, there's these, way marked up value added Moringa products that are organically certified, but from very far away. So this is where the economic studies have to be done. Is it economical to cultivate Moringa in California? We really don't know yet, and it really depends on the market and the awareness level.
And Dr. Harmon, sorry to interrupt. Do you know the nutritional value and how that varies over the lifespan of the plant? So is it more beneficial to harvest early on, like sprouts, for example, where I would imagine there would be higher concentration perhaps of the isocyanates, or is it equally nutritionally valuable to harvest from the older plants?
If you're going for the isothiocyanates, the younger the better. In fact, the seeds are the best for the isothiocyanates. And then if you're going for nutrition, it's recommended to harvest around 30 to 35 days before there's a conversion to more fiber.
Mhm.
So that could mean from a sprout, or that could mean you cut it back and then there's a new growth, right? But yeah, if you're going for the seeds are like 22% Moringa isothiocyanate 1. I mean, you'll taste it. The seeds have a crazy taste to them. But the leaves, it's just like 3%, maybe 1 to 3%. So as I sometimes will say, if you're looking for a more medicinal approach, the seeds are good, and a more nutritional approach, the leaves, you know.
Mhm. And just another quick follow-up question, but is that you've talked a lot about the drying and grinding into the powder, but the way you described it in the beginning, the leaves of the plant also sound quite delicious. So is there a movement, or are people selling the fresh leaves? Clearly it's, I guess, harder to transport, but yeah, is that something that people are looking into as well?
Yeah, and that's really what I'd like to promote through this grant, right? I mean, obviously, like the opportunity to do whatever you want with moringa, but preferably grow it or buy it from somebody who's growing it, because I do think the fresh leaves, I mean, they taste a lot better, first of all. And if you have your own plant, you can just, you know, trim it like you would an herb and add it to your dishes and sprinkle it on, or on top of some eggs, 3 or 4 leaves, you just, you know, sprinkle them on. So they are selling fresh leaves and pods at some farmers markets in California. I don't know of any grocery stores that sell it. I'm sure there are some in some of the Indian and Filipino and Hmong communities. So it's just a matter of this project is supposed to also kind of help connect people that are buying and selling it. Kaying does sell to a little ice cream shop down in LA, and she puts the moringa, the owner puts some of the moringa in. It's almost like a green tea ice cream, right? Or matcha, but it's moringa. So, I mean, that's the hope, is that we get some really interesting restaurants in San Francisco and LA to say, hey, let's put this on our menu, even if it's just a garnish. That would be really cool. So we're trying to promote both, right? That you can grow it and then you can also dry it. And the idea is, through the sequence of the grant, people who wanted to go into a business then could do, like, learn about the processing and preservation so they could make their own products. Like pesto is great. You just add a little olive oil to the powder and it tastes nice. So sorry, I get distracted talking about food. I liked your kind of icebreaker question too.
And there's one more question here in the chat from Wendy Slesser. How can you be sure the plant is growing in healthy soil?
You have to test the soil for sure, or that's basically what we do. And most places can have that done fairly easily. If people are already farming, then they usually have an idea of what's in their soil. And then you can also test the leaves, right? So once you get an extract or a product, then you could send it for analysis. So I send samples to Penn State for $15. I can get a full nutritional panel. $15, I can get, well, not a full, but general, you know, maybe 10 nutrients, and a heavy metal panel as well. So this is what we just did with a graduate student from Brazil who came to kind of up the demonstration. So now we have the moringa tree, where you can see the long kind of green bean looking pods and the flowers. I'll also mention that the flowers are great as a pollinator source. Kaying makes great moringa honey, which is a whole nother industry to think about. And then this is the intensive bed. So just to show, it's kind of a bizarre concept because it's a tree, but it's also like a vegetable. And so I'm even looking for new language. I've even called these like micro forests But, because a lot matters in words as well. So we're working to kind of use this as to bring people in and to show them. And then through the grant, we'll be doing more of these intensive beds. For leaf production, this is great. If you do want pods and flowers, obviously you have to have a tree. So at the student farm at UC Davis, they're going to do both, have some trees on the edge, right? In theory, there's your seed supply as well. You got your bees, and then you grow this intensive bed for production.
Dr. Waterman, I just wanted to let you know that in like 3 minutes, our official meeting time is up. So some people will have to leave.
Okay, I'm going to zip through real quickly. There's some other potential uses for animal fodder, biodiesel, water purification. This is an idea we're definitely putting in active grants for, to use it as a biofertilizer and growth promoter for other specialty crops. And we also, when I was at Rutgers, we hold a patent on the processing of moringa to capture those compounds. So it's been licensed for cosmetic uses to Estee Lauder, but there are other patentable and usable opportunities for entrepreneurs in this field. And really overall, we're trying to address the UN Sustainable Development Goals, and really Moringa, I think, is hitting pretty well on 1, 2, and 3, and several others. So that's really what I've been inspired with. And yeah, I think I can stop there.
There's nothing Moringa doesn't do. This is what an incredible